So my first request to students was to figure out the side lengths of these triangles. So here we have the proportions or the ratios of the sides, and if I give you side length of 1, you can figure out all the different side lengths. Alright, so we're gonna pause for a second. So yeah, okay, let's go ahead and think about what we've been doing. Okay, so a lot of students set up this equation 1 equals 2x and divided by 2 and got x equals 1/2. So once they know that x is 1/2, we can fill that in, right? This is 1/2. And then if x is 1/2, we have 1/2 times root 3, which would just be root 3 over 2. All right, those are very important. You need to understand and be comfortable with these side lengths. That is a length. That is 1/2. I like to think of it as a triangle. If I look at this equilateral triangle, all 3 sides are equal, right? So if this is 1 unit long, well, if that's really 2 equilateral, I chop it in half, then this side length is just half of it. So it has a shorter side, that's 1/2, and a longer side, that's root 3 over 2. Okay? Very important that you are comfortable with this. Alright, then over here we have this, which is actually part of a square, or half of a square. If we cut the corners of the square in half, we have 2 45-degree angles. So let's move that back. What would our ratios be here? What did we find x to be here? Yeah. So who has x for me? Yes. Great. So x is going to be the square root of 2 over 2. And square root of 2 over 2, since they're both x. Okay, so if we set 1 equal to x root 2, 1 equals x root 2, we're going to divide both sides by what to get x by itself? Divide by root 2. Okay, so if I divide by root 2, these cancel out and I get x equals 1 over root 2. But I can't leave it like that, because I need to now rationalize my denominator. So if I rationalize, I multiply by the square root of 2 over the square root of 2. 2 times 2 is 4. The square root of 4 is just 2 on the bottom and root 2 on top. So that's how we get root 2 over 2. Again, a very, very important number when we're talking about the unit circle. Okay? All right, any questions about why we got these numbers, how we got these numbers? You can always find these numbers again, but the more comfortable you are with them, the better it will be. Sorry, just trying to get that off. Okay, so these 2 triangles, incredibly important. Okay. All right. So the unit circle, very special. It is a circle with a radius of 1. 1 unit. That's why we call it the unit circle. It's just 1 unit is the radius. It's 1 all the way around. The center is at the origin, and it's symmetric with respect to the x-axis, the y-axis, and the origin. If I take this top half and fold it, it folds there. If I fold it this way, it folds and it matches up. And if I fold it with respect to the origin, this way over the line y equals x, that works as well. So it's symmetric everywhere. All right. So you guys have these notes. You grab that worksheet on the way in, and all the notes are down because I didn't want you to have to write everything down. I wanted you to be focused on the concepts. Okay? All right. So we are going to let this point P, we got a point P, x comma y, right? All points are an x and a y. So the point P is x, y, we're going to let point P be a point of intersection of the angle's terminal side with the unit circle. So remember we talked about initial side and terminal side? So we're going to say, what if the terminal side intersected with the circle at that point P? If I drop a perpendicular line from P to the x-axis, it will form a right triangle. Do you guys see the right triangle? Okay, can you on your papers draw the little right triangle notation that says that's a right triangle? All right, so we need to remember this is a distance, like 1, 2, 3 units, and then 1, 2, 3. Now, could this be 3? Could the x value be 3? Is there any possibility it's 3? If we are on the unit circle. It's, so the highest it could be, the largest the x value could be, is 1. It's never going to be bigger than 1 because we're on a unit circle. It only goes out to 1. So here, x might be 3/4. And y might be, again, 3/4. I don't know exactly, because I'm not given what the point is. Okay, so we made a right triangle. In this triangle, the side adjacent to theta is along the x-axis and has a length of x. So this is our theta. This is theta. This is our adjacent side, right? And that's our opposite side. And yesterday we talked about opposites and adjacents, right? When we were talking about sine and cosine. The side opposite theta is perpendicular segment and has a length of y. So we have our adjacent side and our opposite side. We okay so far? Any confusions or questions? Okay, next baby step. So we know that the radius of the circle is represented by r, right? So here's our radius, r, and r is 1. The radius is just 1. So we can find the values for sine and cosine. So we know sine of theta would be opposite over hypotenuse, right? So sine of theta is y over r. Sine of theta is opposite over hypotenuse, so it's y over r. And we know that the radius is 1, so it's y over 1. So basically, sine theta equals y. And I put that in, for me it looks highlighted. For you, it kind of looks highlighted. All right, very important. Sine of theta is our y value. Did we kind of follow how we got there? We're on a unit circle, so the radius is 1. Opposite over hypotenuse, we're using the formula for sine to get to that sine value is our y value. All right, our cosine is our x value in the same exact way, that we're going adjacent, the x over the radius. So adjacent over hypotenuse, x over r. So x over 1. So really our cosine theta is our x value. Very important. So instead of x and y, we can substitute sine theta and cosine theta into our point. Which one comes first, sine or cosine? Cosine. Cosine comma sine. All right. So that's, you guys don't have this page because it wouldn't fit on the 8 pages that I had to fit. So instead of x and y, we can substitute sine theta and cosine theta. So if I had this circle, you guys, yeah, I just wrote it at the bottom of your page. So here is my theta, okay? And this point right here that's intersecting the circle and my terminal side, that point, the x comma y is cosine theta, sine theta. Can you guys write that somewhere? Find any point x, y and write cosine, sine on top of it. Cosine theta, sine theta. Yeah.
Wait, does it matter if you put theta next to it, or like when you change it entirely?
Yes, so you need to put theta because it's saying cosine of this angle right here. If you just write cosine, it's incomplete. It's saying, because cosine has to be from some angle or of some angle. Okay? So based on this angle, the cosine of that theta is something. Okay? All right. Yes. Question. Okay. When you figure it out, ask me. Okay. All right. So I want to show you about the symmetry of the unit circle. So there's a bunch of symmetry. We were talking about reference angles. This is 30 degrees, right? And this also is 30 degrees. So that's a reference angle of 30 degrees and 30 degrees. But what is this actual angle? So here's 30 degrees. What would that be? 180 minus 30 would be 150. Okay, so I'm going to put it like right here, 150 degrees. So 30 degrees is here. 150 degrees is here. It also has a reference angle of 30. This would be 180 plus 30. So that would be what, 210? 210 degrees. That also has a reference angle of 30. And what else? 360 minus 30? 330. Good. So all of these angles are going to have some very interesting similarities. There are some subtle differences. There are some subtle differences, but they're very, very, very similar. So you could almost memorize this first quadrant right here of the unit circle and just figure out these three real quickly based on that first quadrant because of all of this symmetry. Okay, so let's think about when we're at 30 degrees. 30 degrees, 60 degrees, 90 degrees. When we did that triangle earlier, remember this side was 1? The shorter side was how high? What was the length of the short side? Across from the 30-degree angle. Yes, Mariah. Thank you, it was 1/2. Alright, so the height here is 1/2. Is that my x or my y? If I'm going up, that's my height. That's my y, good. What was my x? What was that length of that triangle? Or what was the other side of that triangle? Root 3 over 2, very important. Root 3 over 2 is the length and the height is 1/2. So my ordered pair right here at 30 degrees would be x comma y. The length I went out on the x and the length I went up on the y. And really this is just a triangle, a 30, 60, 90 right triangle. And we know about the lengths and we're plugging in the distance here, root 3 over 2, and the distance here, 1/2. The x coordinate and the y coordinate. Is everybody okay with this so far? Okay, now we don't only just know 1, we actually know, look, this right here we went back and up. Well, this is back root 3 over 2, up 1/2. It's the same exact triangle, right? And then we go down 1/2, right? And that's still root 3 over 2. So what's reversed? You said something about reversed. Tell me about what this ordered pair would be. Root 3 over 2, what would I put there for my x coordinate? Negative root 3 over 2, yeah. Negative root 3 over 2 and 1/2. So I go back and up. Cool. I would like you to please fill in these two ordered pairs, right here and right here. You have the same coordinates, but with different signs. And I see actually a hint right here. In this quadrant 1, we have positive, positive. In this quadrant, we have negative, positive. In this quadrant, we're going to have negative, negative. And over here, we're going to have positive, negative. Okay, so go ahead and fill that out real quick. Okay, so our coordinates will be negative, negative, so negative root 3 over 2, and negative 1/2. And over here, positive root 3 over 2, negative 1/2. So, actually what we just figured out, we figured out that the cosine of 30 degrees is root 3 over 2. Because you guys told me the coordinates were cosine theta, sine theta. Well, if my theta is 30 degrees, we just figured out that cosine of 30 degrees is root 3 over 2. And we also know that sine of 30 degrees is 1/2. Whoa. We're doing trig. Alright. So now we're going to go to the other two important angles and do them. Are we ready? Okay. Okay, so our next angle is 45 degrees. So now we're looking at that root 2 over 2, that triangle that was a 45, 45, 90, right? Do you remember from the warm-up we did? Yeah? We're ready? We're good? Okay. Alright, so this is 45, this is also 45, and this is 90 degrees. So go ahead and put in that 90 degrees. So this was a nice one. It had two side lengths that were exactly the same, right? So how much was my x value and how much was my y value? What would that one be? Root 2 over 2, root 2 over 2. Very good. And then over here, I'm going to go back root 2 over 2, up root 2 over 2. So I'm looking at the x-coordinate and the y-coordinate. To get to this point, I'm at negative root 2 over 2, positive root 2 over 2. Back and up, right? Over here, we're going to go back and down. So to go down to this one, we're going to go back and down. Both are negative. So this point would be negative root 2 over 2, negative root 2 over 2. And this point, what would that be? Positive, negative. So positive root 2 over 2, negative root 2 over 2. Alright, so again, just to emphasize, this says what? Please write a sentence that, what does this tell you the answer to? Cosine. Not, this one is cosine, first one is cosine, the second coordinate is sine, right? Sine was the height, cosine was the x-coordinate. Okay, so this says cosine of 45 degrees equals root 2 over 2. Okay? Anybody lost yet? Alright, we're going to do one more, and then we're going to look at how to look at degrees and radians around the circle, if we have time. Okay, so here we have 60 degrees. So this again is our 30, 60, 90 right triangle. But now the short side is here and the long side is here. Now it's oriented differently. Before it was kind of like laying down and now it's standing up. So this is our 30, 60, 90. I like to think of it as the short side and the long side. The shorter side is half of my radius. So my short side is 1/2. Right? And my long side was what? What was the other coordinate? Root 3 over 2. Good. So, this ordered pair would be 1/2 is my x, and root 3 over 2 is my y. Alright, please go ahead and fill in the other 3 coordinates on the unit circle on your paper. Alright, so those are the other 3 points. We are going to now look at something, actually the whole next slide, it's filled in for us. Wow, that's a lot, but if I wanted you to see that there's a lot of symmetry. So if we're okay with a blue, a green, and a yellow, and we get all these 30, 45, and 60 degrees, we can take that and use symmetry and just say, oh, well, let me just reflect them over here. Let me reflect them down here. Let me reflect them over here. And really, all I have to do is change the signs to get all of these answers, and those answers. Okay? So, I don't want you just to look at that and fill them in on your homework sheet. That's really just hurting you. So, can we find, is there a blank space anywhere on that? Not really. Okay. Alright. So I just need your attention up here. And like I said, every day and for every topic, this is the most important thing. You need this. You need to understand this. So there's 2 parts. There are 2 things that you have to do. You have to label degrees, and you also have to label radians. Now the students who have tried to take their degrees and convert them to radians for every single one have taken forever, and they've been really frustrated because that's like an incredible amount of work, and nobody should work that hard. Okay, if you tried to take all of your degree measures, so I'd like you to find some scratch paper. Draw a big circle. Put your x and y axis on there. I'd like you to do a 30 degree, a 45, and a 60. Alright, it's not exact, but it's good enough. Alright, I just realized we didn't do the quadrantal angles, but quadrantal angles are actually pretty simple. We just need to think about what's the ordered pair on this quadrantal angle. So can we think about what's the ordered pair right here? X is what? We know the radius of our circle is what? Unit circle is 1. So I went 1 unit to the right, and how much did I go up or down? 0. Alright, and to go up here, I have to go 0 in the x coordinate and 1 in the y. Over here, I went back 1 in the x and 0 in the y. And here's 0 in the x and negative 1 in the y. So just be really careful about what are your quadrantal angles. So what I'd like to do right now is label degrees and then label radians, because that's part of your homework and you need to understand how to do it. The degrees I think are a little simpler than the radians, so we're going to go quickly through the degrees and spend more time on the radians. Okay, so degrees. We have 30, 45, and 60, right? This one's 90. We know this one's 180. We know this one is 270. We know this is 0 and it's 360. You need to put degree symbols so that I'm aware that you're talking about a degree measure. So this is the first quadrant, just 30, 45, 60. Okay? Then, okay, well to get from here to here, well, how far apart are these guys? Okay, so it's 30 degrees more. So 90 plus 30, 120. Okay, how far apart are these guys? Okay, so we have 15 degrees between here, we have 15 degrees between here, and we have 30 and 30. So that can kind of help you to get to each next one. Now if you make a mistake and then everyone else is based on that last one, you kind of have a checkpoint at 180. So it should be plus 30, plus 15, plus 15, plus 30. Okay, so we added 30, we'll add 15, so 135, add 15 again, 30, 40, 50, and then plus 30 again, and we should match back up. So please continue that pattern, plus 30, plus 15, plus 15, plus 30, and you can get all your degrees in there. So take a minute to... Alright, so those are all of our degree measures. Now, when we're talking about radians, it's a little more exciting. I kind of want to draw a whole nother picture. No. Yes. No. Yes. Yes. Do I have time? I do. I have time. Okay, we're going to draw another picture. This is going to be a really long video. I'm sorry. Alright. New picture. I swear I can still see it. Do you guys see it on the board? I don't know if it's like virtual or if it's just my pen. Okay. Here's it. Oh, that is not so pretty. Let's try that again. It's a little better. Okay. Not a fan. Halfway, 15 above, 15 below. Halfway, 15 above, 15 below. Sorry, this is not perfect, but it's what we get. It's not so pretty. That's right, it's good enough. Okay, I am going to use a highlighter and really fancy colors because I saw Nezzy doing that and it looked beautiful, so I want mine to look as beautiful as hers. Here we go. Okay, when we're talking about radians, we need to be able to count in fractions. Yay! Other people are using colors too. Okay, so we need to be able to count in fractions. So like 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3. I just counted in fractions, right? I'm just counting up how many thirds I have. So, when we're talking about radians, how many total radians are there in a whole circle? 360 degrees, but how many radians? What? No? So we were talking about circumference of a circle? Yeah. No? Okay. So here we have 0 oh, this is not a pen. Okay, let's try this again. This is 0 radians. If I go all the way around the circle, okay, so to go all the way around the circle, we have 2 pi. 2 pi's all the way around the circle. So 2 pi is a full circle. So if I go half of that, I would be where? 1 pi. Okay. All right. So what if I went half of that? What if I counted by halves? So here's 1 full pi, 2 full pies. Okay, but let's do half pies. Where would a half pi be? 90 degrees. Good. So I'm going to go up here. This is pi over 2. So that's 1/2 of pi. Does that make sense? Okay. And then so now let's count by halves of pi. So 0 pi, 1/2 pi, 2/2 pi, which simplifies. 3/2 pi, right? 3 pi over 2. And 4/2 pi, which is really just 2 pi. Okay, so we counted in our halves. Let's count in thirds. What would a third of pi be? Or let's think about 180, right? We know 180. Cut 180 into 3. How many degrees is that? 60. Okay, so 1/3 is going to be here. So this is pi over 3. 1/3 pi, 2/3 pi, 3/3 pi. But I already have 3/3 pi. It simplifies. 4/3 pi, 5/3 pi, and 6/3 pi. Well, that's 2 pi. Okay, so my thirds are 60 plus 60, 120, and 180, right? So 60, 120, 180, these are thirds of pi. And if you think about it, oh, I was going to do the highlighter. So the highlighted, if I highlight this section, this is 1/3 of pi. They should be the same shape, same size. I kind of approximated but 1, 2, 3. There are 3 sections here that make up pi. So 1/3, 1/3, 1/3. Okay? Alright, let's try, which will you try next? We haven't labeled everything yet. Quarters? Okay, let's cut them into quarters. If I took 90 degrees and cut it in half, where would I be? 45. Alright, so when we're doing quarters, we're talking about pi over 4. So we're talking about 1/4 pi. Oops, I want green. Pi over 4. 1/4 pi, 2/4 pi. Well, that simplifies to 1/2. So that's 2/4. 1/4, 2/4. 3/4. 3 pi over 4. 4/4 pi. 5/4 pi. 6/4 pi. That simplifies to 3/2. What was that? 6/4? 7/4 pi. And 8/4 pi. Whew. We have one last one to do. What would 30 degrees be? It would be a sixth. Good. So we want to find the sixth. I guess I'll do pink. Okay. So here we have 1/6 of pi. Now if we do sixths, we could actually get the thirds as well. So I could go 1/6, 2/6, that simplifies, 3/6, 4/6, 5/6, 6/6. So there should be 6 chunks there, right? 1, 2, 3, 4, 5, 6. Then I keep going. 5/6, 6/6, 7/6. That's not a 7. Alright, let's try it again. 7 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And we're done. Wow. That was a lot of work. But it was worth it. Woohoo! Okay, you gotta get comfortable with this and counting them out. So we need to practice. Those of you who have already filled in a unit circle, I want you to do a whole nother one for homework. I have a sheet actually of 4 where you can just practice filling it in 4 full times. Does anybody want those? Or maybe there's 8. Maybe it's on the front and the back. Yeah? Yeah? Everybody's wanting one right now. I promise. To you video people. Uh-oh. Uh-oh. Oh no. My microphone was up by my ear. Does that mean it didn't get any of it? Oh. Okay, well I hope it worked.